So in this video, we're going to talk about the acidity and which acid is actually stronger, right? Now I'm going to give you a hint. I'm going to actually give you guys a pK values, but the idea is that the concept, I want you to get the concept of why this acid may be stronger than this acid. So I have four structures. Here is structure A. Now this is it after it gets deprotonated, right? Now this is structure A. The pKa is actually 25. Structure B, this is structure B, and the pKa is equal to 23. This is structure C, and the pKa for the deprotonated proton, where the negative charges are, is 8.8. Now, the last one we're going to talk about is structure D. And its pKa is actually 4.2. So just based off the pKa, we know that structure D is the strongest acid because, again, we know the trend. The lower the pKa, the stronger the acid. But we want to break this down. So in other words, why structure B, right? So structure B is actually a stronger acid than structure A. We could agree in that. But why? The idea is that look at where the negative charge is at on structure B versus where the negative charge is at on structure A. The negative charge is on an electronegative atom. So nitrogen is more electronegative than carbon, and so nitrogen can better stabilize the negative charge. So this is why structure B is actually a stronger acid than A. It is more stable, right? So nitrogen has no problem handling the negative charge since it's more electronegative. Carbon, on the other hand, is less electronegative, and so it may have a little bit of problems handling the negative charge as opposed to that of a more electronegative atom such as nitrogen, right? So this is why structure B is a stronger acid than structure A. Now, why is structure C a stronger acid than B, right? So structure C is a stronger acid than B, and it's actually immensely more stronger than B. Why? Well, if you look, the negative charge is both on the nitrogen. But what makes structure C much more acidic is the idea of inductive stabilization effects from the adjacent oxygen atom. So in other words, remember that all these negative charges are coming from protons that have been deprotonated, right? So all these are coming from stuff that have been deprotonated, right? This nitrogen in C has an electronegative oxygen close by, and so that's what we call induction. We call that the induction effect, right? So it's better able to stabilize the negative charge because we have another, even a more electronegative atom adjacent to where the proton was, or in other words, where our negative charge is actually currently. Whereas B, yes, we do have the negative charge on the nitrogen, but we have we have nitrogen directly beside it, right? Now remember, we both have a ketone group adjacent, but it's 2 carbons away, right? Or it's not directly adjacent to it, right? Whereas we have an oxygen group in the form of the alcohol, or OH, directly adjacent to the nitrogen group. And so this is why C is a way stronger acid than B, because of the inductive effect, right? So anytime you have anytime you have an electronegative atom directly adjacent to where a proton would be deprotonated, uh, that tends to be more acidic. Now, how can we explain why D is actually a stronger acid than C? Well, now this differs, right? C, even though B only has, okay, well, it doesn't even have an electronegative atom directly adjacent from it, as it doesn't have an electronegative atom directly. So for D, it doesn't have an electronegative atom directly adjacent to it, apart from the carbonyl group that's right here. But this also has a carbonyl group. But in fact, we just talked about the inductive effect, and you would think that C should be more acidic than D, but here's where resonance stabilization comes in. Right? So at this junction, there's no way we can actually draw a resonance structure once the proton gets deprotonated. Whereas here, I could actually simply, and let me zoom out a little bit. For here, I could actually simply move my negative charge around. Right? So for here, because I have 3 pairs of lone pairs, I could actually form a double bond here and then kick this single bond on the form of the oxygen on top. And so in other words, this now has the negative charge. This oxygen now has a negative charge. And this has my double bond. Alright? Now, keep this in mind. Whenever a molecule gets deprotonated and you're wondering if it's a stronger acid, you should always also think about resonance. If you're able to draw a multiple resonance structure for the molecule, that means that it can better actually stabilize the anion or stabilize the negative charge. Even so, better than just having it on an electronegative atom. Now, what also should be important as well for this, even though resonance is a major contributor as to why D would be stronger than C, you should also see that the negative charge is actually on oxygen, which is more electronegative than nitrogen. So that also plays a minor role, but again, resonance stability is the major factor here.